Hello everyone, I welcome you all to today's session wherein we will be discussing some of the basics of the topic time and distance. So I plan to do around 3 to 4 videos on the topic, right? And this is slightly wider topic which would be covering several subtopics under it. For example, topics like the application of variations, topics like relative speed, average speed, etc. Right? So we shall be doing that in subsequent videos also. Right? So in today's video, we shall be focusing on some really basic concepts of time and distance, and as you all know, the topic time and distance is one of the important topics that you have from point of view of competitive exams, including CAT. Right? So every year you get to see a few questions coming from this area and maybe one odd question coming from time and work area, which is also a related concept. We have already covered time and work in the previous videos. Right? So today we will start with time and distance, and let's get started with it. So the very first concept, sub-concept that I would be discussing here with all of you is the concept of units conversion. So sometimes in time, speed and distance problem, you would be given with, of course, the units of speed, distance and time. Now the units could be multiple. For example, speed can be measured either in meters per second or in kilometers per hour or in miles per hour. Likewise, time could be measured in either minutes or seconds or hours or days perhaps. So there could be several units, but commonly occurring units that we have in our competitive exams for the three variables that we will cover, which are distance, time and speed are the various units are. So commonly occurring units are distance sometimes is measured in terms of kilometers. So if distance is measured in kilometers, in such a case, we take the time in hours. So distance, if it is given in kilometers, generally we take time in hours, and thus the speed, which is defined as distance travelled per unit time, will be given in kilometers per hour. Now some other times, distance will be measured in terms of meters. In such cases, generally we take time in seconds, and hence the speed will be measured in meters per second. So these are the two common set of units that we take for the variables that we come across in the topic time, speed and distance. And sometimes what would happen is, we have the following equation, right, which we all already know. I have not discussed it, but I am sure you know, which is speed is defined as distance travelled per unit time, which can also be written as distance is nothing but product of speed and time. So that means if I multiply speed with time, given speed of the body, given time taken for travelling a certain distance, the product should give me the distance always. But there is a catch here. Now the speed and time should have compatible units, meaning if time is given in hours, the speed cannot be in meters per second. So speed then we'll have to consider it in kmph. You can multiply the two and you can get your distance in kilometers. Or if you have your time given in seconds, then your speed cannot be in kilometers per hour, it should be in meters per second, and when you multiply these two, you will get your distance in meters term. So you have to be careful about this compatibility between the various variables that we have, the units of the various variables that we have when we are solving our problems in time, speed and distance. So sometimes there would be a need of converting one unit to the other. For example, very commonly we convert speed. So speed, for example, if I want to convert meters per second to kilometers per hour, so the conversion factor that we'll be using for this conversion is, the factor is 18 upon 5, which is very easy to calculate because we know kilometer is 1000 meters, hour is 3600 seconds. So kilometer by hour will give you 1000 by 3600, which is nothing but 5 by 18. And when you cross multiply this 5 by 18, it will become 18 by 5. So it's better we simply remember meters per second to kilometers per hour, the factor should be 18 by 5. And if you want to do the reverse conversion, kmph to meters per second, the factor should be 5 upon 18. Okay, this is how we convert one unit of speed into some other unit depending on the context that we have in the problem. So this is the very first thing that I would like to cover, right? Of course, as far as your Indian MBA entrance exams are concerned, we need not bother about meters per second, sorry, miles per hour. We need not bother about miles per hour, but just in case if you want to cover that as well. So, one more unit that we have for speed is miles per hour. So, miles per hour, if you want to convert this into kmph, so the factor that we'll be using here is 8 upon 5. And kmph into miles per hour, the factor will be reciprocal of that, 5 upon 8. Okay. So, this is how we can convert, right, one unit of speed to some other unit of speed, alright. And by the way, the conversion factor is 8 by 5 because we know that 1 mile is nothing but 1.6, which is 8 by 5 kilometers. So, thus 1 mile per hour is 8 by 5 kilometers per hour. So, these are some basic details from the units conversion concept, the very first point in time, speed and distance. Now, we shall take up a small problem to illustrate the application of this. You can just copy this. Let's go for the question now. So, if you read the question, it says Abhishek wants to travel 120 kilometers in the following manner. He starts the journey at 9 AM at speed of 8 1/3 meters per second. So, let's say Abhishek is starting at this point. Say this is S and he's starting at 9 AM. So, when he started, his speed was 8 1/3 meters per second. And travels for 1 hour. So, he is traveling like this for 1 hour. So, please note that the time given is in hours. So, my speed cannot be meters per second as we discussed. So, let's say this is the first point where he reaches, right, after 1 hour. After each hour, he rests for 15 minutes and resumes his journey at double the speed. So, at point A, he will be reaching here at 10 AM. After 1 hour, he will rest for 15 minutes. That means he will commence his journey, he will continue his journey at 10:15 AM from point A. He will again travel for 1 hour, say he is moving to B. But this part of the journey, please understand, is being done at double the speed. He says double the speed. So, for example, if the speed here was 10 meters per second, it will be 20 meters per second for the second part of the journey. Again, this is also for 1 hour. So, from 10:15, he will reach here at 11:15. Again, he will take a halt, alright, for 15 minutes. At what time this way he will cover 120 kilometers? At what time will he reach his destination? Let's try to figure this out. So, I already told you, since time is in hours, let's convert speed into kilometers per hour. So, 8 1/3, 8 1/3 is nothing but 25/3 meters per second. To convert this into kmph, we'll multiply by 18/5 factor. So, when I do this, it's 5 times. 6 times. So, it's going to give us 30 kmph. So, the speed at which he is traveling, I won't take it as 8 1/3, I'll rather take it as 30 kmph. He is traveling for 1 hour. So, that means this distance travelled will be 30 kilometers. Speed into time. Time is 1 hour, speed is 30 kmph, product of the two will give you the distance. Then he is halting for 15 minutes, etc. Here, his speed will be, please understand, double. So, it will be 60 kmph. So, that means this distance travelled will be nothing but 60 kilometers, because here also he is travelling for only 1 hour. So, overall from S to B, he has already travelled 90 kilometers. He only has to travel 120 kilometers. So, that means, can I say, at 11:15 when he reaches here and when he resumes his journey at 11:30 after taking a 15-minute break, he only has 30 kilometers to cover. So, this distance here to reach his destination is only 30 kilometers. Let's say this point is C. But after the second halt, his speed will be again doubled. So, the 60 shall now become 120 kmph. So, now you know the distance, you know the speed. So, can we calculate the time taken for travelling BC? Of course. So, can I say time taken for BC, this distance, will be nothing but the distance to be travelled, distance by speed, which is nothing but 1/4 of an hour. And if you look at it in minutes, it's 15 minutes. So, he will cover the remaining distance in the next 15 minutes and Hence, can I say after 11:30 he will take 15 more minutes to reach his destination. Hence, my answer, at what time does he reach his destination? Can I say it will be nothing but 11:45 a.m. So, this is going to be our answer, and this is how we can easily get to our answer by just paying attention to the units. By paying attention to the given conditions, we can easily mark the answer as 11:45 a.m. I hope we are clear with this. Moving on. So, thus units are important. We need to pay attention to this minor concept also. Now, let's move on to the next concept of variation. So, the concept of variation will be pretty important as far as your time, speed and distance topic is concerned, more important than time and work, right? The concept of variation will be more important here than in the other topic that we already covered in this series of videos, right? Time and work. So, let's try to pay attention to this variation concept a little bit, and then we'll solve one example. So, we have three variables here: distance, speed and time. Now, if you look at the relationship between these three variables, we'll get the following relation. We may say that distance is directly proportional to speed, directly varies with speed when time is constant. So, this further means what? If distance is directly proportional to speed, the ratio of distances in two different occasions, two different instances will be equal to the ratio of the speeds in two different cases. So, for example, if I travel at 30 kmph, I cover distance d. I travel at double the speed, 60 kmph, I will cover double the distance, 2d. So, whatever is the ratio of distances, same will be the ratio of the speeds also. So, d1 by d2 is equal to s1 by s2. So, this can be used whenever your time of travel is constant. One more, we can also say distance is directly proportional to time when speeds of the individuals involved are constant. So, say there are two people who are traveling at same speed, they want to cover a certain distance, let's say 100 kilometers, both will take the same time. Alright, for example, if one person, let's say, is covering 100 kilometers, he would take 1 hour. Some other person who is covering 300 kilometers will take 3 hours because their speeds are constant, their speeds are same. So, in this case, we may say if d is directly proportional to t, ratio of distances will be equal to ratio of the times in the two instances. Now, we get to the most important variation rule. So, I am writing it in different ink, right, to differentiate. So, that is speed and time relation. So, what is the relation between speed and time? If you go at higher speed, you will take lesser time, right? So, they are inverse variation or inversely proportional. So, this will be true when distance is constant. So, here what will be ratio of the speeds? That will be inverse of the ratio of the times. So, S1 by S2 is going to be equal to T2 by T1. Just one more small point I would like to share, a trick I would like to share. Whenever distance is constant, that means speed is inversely proportional to time. That further means their product should be constant because their product is nothing but the distance. Distance is given to be constant. Whenever product of two variables is constant, fixed, then if one variable changes, the other variable will also undergo some kind of change. For example, let us assume if S increases, in such a case, can I say T will decrease so as to counter the increased effect of speed. Speed increases, overall product will increase. In order to counter that, time will reduce. Or if speed decreases, the time will increase so that the product still remains the same. Meaning, if let's say speed becomes P by Q times some fraction I am taking into S. So, say 7 by 3 times or 3 by 2 times or 4 by 3 times, something like this, some fraction, right? P by Q times of S. Then in order to counter this, the time should become Q by P times. I hope we understand this. So that the effect of P by Q is cancelled out with this Q by P. Effectively, P by Q into Q by P is 1. So, whenever speed becomes 3 by 4 times, time will become 4 by 3 times. Right? I hope we can see that. This is one way of looking at it. Another point is, look at this one also. Whenever product of two variables is constant, Here, if one variable increases, the other will decrease for sure. Now, there is a relation, there is a particular way in which the increase and decrease happens. If speed increases by, let's say, a fraction a by b, 3 by 4 times, 3/4 increase, 1/3 increase, 2/7 increase, any fraction, it increased by a by b times. Please understand this a by b and this p by q are different. Here, p by q is a multiple. So, speed is becoming p by q times. Here, speed is increasing a by b times. There is a difference. Then, the time will reduce by the following factor, a upon b plus a. Or, if speed decreases, let's say by x by y times, some fraction, then time will increase by x upon y minus x. So, these things can be easily proved, but in this short video, I am not going to go there, the proofs of all that. You can just maybe make a note of this. At this moment, I would like to just highlight for more detailed discussion, see, because these are very small videos duration wise, alright. So, here we will not be able to go to the entire depth of the concept, alright. However, I have shared what is important, right. But if you want to find out what is the reason behind it, how are we doing it, alright, or for more detailed discussion on these things, I would suggest that you subscribe to this channel, right, for more such video, and also reach out to the nearest time center, right, wherein you would be getting details about all the latest batches that we are starting for CAT and other courses too, alright. Let's get back to it. So, this is the basic discussion with respect to variation. In today's class, in this today's video, I intend to take one small problem on variation. Next video, you'll have to wait for that. We'll have one more video, one more question pertaining to variation, But for now, let me just clean this. Let us solve that question. So, look at this question. Pause the screen. Try out this question yourself once. See if you can solve it. I, however, here in the class would be discussing it, alright. You can solve it, check your answer, and then verify once we are done with the discussion. Check what is your answer and what is the answer that we are getting here. So, the question, it says Ashok travels at a speed of 40 kmph and reaches his office 10 minutes later than the usual time. So, that means if Ashok was supposed to reach at 9 AM, if he travels at 40 kmph, he will reach at 9:10, 10 minutes late than the usual time. So, usual time means, let's assume something like the time at which he was supposed to come to office, right. So, 9 AM is the time. So, he will reach at 9:10. If he travels at 45, that means he is increasing his speed, he is going little rush, right. He would reach 5 minutes earlier than usual time. So, usual time we have taken it as 9. Now, we will reach 5 minutes before that, right. Find the distance he travels. So, we can solve this question in many ways. For example, one of the ways could be like this. Let us say the distance is d. The distance he is traveling is d kilometers. So, in the first case, he is traveling at 40 kmph. So, what will be time taken in the first case? It will be d upon 40 hours, right, distance by speed. What will be time taken in second case? It's going to be d upon 45 hours. Now, when I find the difference between these two times, so what will be t1 minus t2? So, t1 minus t2 if you will do, this will be d by 40 minus d by 45. If you will take the LCM, it's, what will be the LCM? 90, 180, 360, right, 360. 9 times and 8 times, so it's going to be d by 360. Okay, 40 into 9, 360, 45 into 8, 9 minus 8, 1d. So, d by 360. This will be equal to t1 minus t2. So, basically the difference in the times. Now, what will be the difference in the time? Please note, in this case is coming 10 minutes later. So, if his usual time is t, he will take t plus 10 minutes. In the second case, he is reaching 5 minutes earlier. That means if his usual time is t, he will reach t minus 5. So, what is the time difference between these two? Subtract them. So, when you will subtract them, you can notice that the gap is 15 minutes. T plus 10 minus t minus 5, when you will subtract it, you will get us 15 minutes. But since we want our time in hours, because we are taking distance, speed, etc. in kilometers per hour, I will write by 60. So, 60 will go 6 times, and when you solve it, you will get the value of d as 90 kilometers. I hope this is okay. This is clear. But the same question now can be solved using the concept of variation also. Notice how. In the first case, we are traveling at 40. What is the time taken? it is 10 minutes more than the usual. So I am taking the usual time as t. Second case 45, what is the time taken? 5 minutes earlier than the usual, t minus 5 minutes. So this is the speed factor, this is the time factor, variable. So what is happening to speed? Please notice, speed is increasing. So it is increasing by how much? Just a minute. Speed increases, it is increasing by how much? It is increasing by 5 on 40, it is increasing by 5 units on 40, which is nothing but 1 by 8 increase. And we know in this case is travelling the same distance in both the cases. Whenever distance is constant, if speed increases by a by b, the time will reduce by a upon b plus a. If speed increases by a by b, that is 1 by 8, can I say time will reduce by, this reduction in time will be 1 by 8 plus 1, which is 1 by 9. So this time is, this entire t plus 10 is going to reduce by 1 by 9, right? So can I say the difference between these two, which is nothing but 15 minutes, is going to be equal to, 1 by 9th of the usual time plus 10 minutes. So this variable is reducing by 1/9, and this difference we know is 15 minutes, right? 10 minus of minus 5, 15 minutes. So thus when you will solve it, you will get the value of t as what? T plus 10 as what? Sorry, not t, but t plus 10 will be 135 minutes. Now 135 minutes is nothing but 2 hours and 15 minutes. So 2 1 by 4 hours, which is nothing but 9 by 4 hours. So we know the time in this case, and you also know the speed in this case. Just multiply the two, you will get the distance. So distance will be nothing but 40 into 9 upon 4 kilometers, which is nothing but 90 kilometers. So these are the two ways in which you can go about solving it. I personally prefer this because this, for the sake of writing here, explaining here, has taken a few steps. But when you will do it mentally, alright, or you do it yourself, you will take a lot lesser step than what we have written here. So this is generally a preferred approach than this regular approach. However, both are going to take presently the same amount of time. But I hope you have followed that, because this is very self-explanatory kind of. The steps and all are very convenient, easy to follow. I hope you have followed this. Okay, please copy this. So with this, we have come to the end of the session today, right? So in this video, we have looked at a couple of aspects of time, speed and distance. Next set of videos, we'll look at more things, all right? So just to recap, we looked at the importance of units, all right? We have solved an example. Second thing we did was, we looked at the importance of variations in the concept of time, speed and distance, all right? So let me end the video here, all right? Thank you and all the very best.